So in this next video looking at angles, we're focusing on angles on parallel lines. Now parallel lines are lines that never meet when extended, and that's one of the key words that's usually defining of parallel lines, is that when extended the lines will never meet, and also that the distance between the lines is always the same. So if you look at these two sets of parallel lines, you can see on your screens, these two lines here are parallel, so they are parallel. However, with these two lines here, we can see that although the lines never meet, that one, if I extended the lines, that those lines would eventually cross, and also that the distance between the lines is different as you go along, whereas here, that the perpendicular distance between these lines are always going to be the same, to the point where you can make it look like a ladder. Now, if lines are parallel, then they usually have markings on the line. Now, this is either using diagonal dashes or with arrows. Now, if there are multiple parallel lines that you can see, then the lines that are parallel will have the same number of dashes or arrows. So what I mean by that is if we take this parallelogram, and in a parallelogram, you've got two sets of parallel lines. So I can mark one set of parallel lines. So one set are these two lines here, which I've just made a very failed attempt at drawing along that white line there. And so what I'll do is I'd put an arrow on there to represent that those two lines are parallel. Now for the other sets of parallel lines, which again I'll just use pink and hopefully have a bit more success at going over these lines, then rather than using one arrow, because I've already used one arrow on the two green lines, instead I'm going to use two arrows. So those two lines that with the same number of dashes or with arrows will imply that those lines are parallel. Now, one thing you do need to be aware of is that particularly when using dashes, that sometimes a dash on a line can sometimes also mean that they are equal length. So you kind of just got to relate it to what type of question that you are working with. So for example, with dashes, if they are implying that they are the same length, then you tend to find the dashes are perpendicular to the line. So it's like a right angle in terms of lines. However, if they were implying that they're parallel, then it will just be a non-perpendicular dash that goes from there. So for example, I could have something that looks like that to represent that the two opposite lines are parallel to each other. Now in terms of angle types, again let's just quickly go through a quick refresh on the types of angles you can have. So an acute angle is an angle that is between 1 and 90 degrees. An obtuse angle is an angle that is between 90 and 180. A reflex angle is an angle that goes beyond 180 to 360, which again in this particular topic a reflex angle is going to be quite rare. And a right angle is basically an angle that is 90 degrees and usually represented with a little box, because in a square the interior angle is 90 degrees, so it should fit quite flush in the corner of that angle if it is right angle. Now the next thing we move on to is angle notation. Now because we are finding angles, now commonly a question in an exam or test will basically tell you what angle to find. So for example, it might say find the angle X. However, in more high level questions, they might ask you not marking of the question, they might give you an angle that you need to work out using angle notation. Now angle notation is usually done by either a little angle symbol, which is before the three letters, or it's giving three letters with the middle letter having a little hat or a little angle hat on top of the middle letter. Now basically what this angle ABC is, so in this particular question we're asked to find or mark the angle ABC. Now what you do to find out what angle that represents is you take the first letter, which is A, you then draw a line to the second letter, which is B, and you then draw a second line from that middle letter to the third point, so that'll be C. So the angle I've created is this angle here. So this angle here would be angle ABC. Now again, similarly, if I pick another colour, so let's go for yellow. So here I've got another type of notation, but it basically means the same thing. So it's the angle created when you start at B, so I'm starting at this point here. I'm then going to go to C, and I'm then going to go to A. So therefore the angle created is this angle here. So that would represent angle BAC. Now angle BAC can also be written as ACB with the middle letter having a little hat. But basically the angle that you're looking for is usually the middle letter, and it's basically created from the two letters that are at either side of it. And then the third angle, which I'll do in, let's see what colour that will come up, let's go for green. So here I've got the angle BAC, so I'm starting at B. I'm then going to go to, let's actually pick another colour, so let's go for red. And so just get rid of that. I'm going to go for red. So I'm starting at B, I'm going to go towards A, and then I'm going to go to C. So it's this angle here is the angle BAC. So always look out for that type of notation. But like I said, depending on what level paper you're working at or what level, the whereabouts this question is, a question will either be marked on the angle. So for example here, let's just call this angle A, or it will give you angle notation in which it's just something that you need to be aware of. So angles in parallel lines. So when you have a series of parallel lines, angles are created. These angles have relationships to the other angles. Now without measuring, we can use these relationships to work out the sizes of these angles. So as you can see here, we've got two sets of parallel lines, and you can see that all the different angles that are created by those four lines that we have got on the screen. And a typical question would ask you to find out what each of those angles are when they give you one of the angles. So in terms of the angle relationships in parallel lines, now it's really important that you learn the official names of these angles. Now, although majority of the relationships will resemble certain letters, which we will go through, which is always useful to know, particularly when you're working out the actual answer to a particular question, but when you're explaining it, it is really important that you use the correct names of these types of angles. So the first relationship we're going to look at is what we call a corresponding angle. Now, a corresponding angle is when you've got two angles that are kind of connected to make like an F. Now the important thing about corresponding angles is that they are the same. So if I mark on this diagram an F, you can see that the F is represented by the pink line along this diagram, but these two angles here, entrapped by the letter F, are going to be the same. Now as you can see that they both could be acute, they both could be obtuse, but those two angles there would be the same. Now again, the reason why we don't no longer call this, or I say we no longer call these an F angle, is because Fs can appear in different variations. So for example, if I take this diagram here, if I mark an F, that's the wrong way round, that these two angles here would also represent a corresponding angle, and therefore those angles will be the same size, along the idea that these lines are parallel. So one thing I should do is mark which lines are parallel, like so. So let's have a look at where we can find these potential Fs. So again, looking at this second diagram, I can see another F. So I can see another F that looks like this. So you can see how it's upside down. So this angle here and this angle here would therefore be the same. And likewise, if I find this third diagram, I can see an F that looks like this. So therefore, these two angles would be the exact same. And likewise, if we get different colours, let's go for orange. So I can find an F that looks like this. And so therefore, these two angles would be the same. And if we go for another colour, which one I would not use, red. So again, I can find that, draw an F that looks like this. So these two angles would be the same. And on the final diagram, again, there's a different variations where you can see an F. I can see an F here. So therefore, these two angles here would be the same. I can see an upside down F. So these two angles would be the same. I can see another F. So these two angles here would be the same. And I can see, let's go for yellow, I can see another F. So those two angles would be the same. So those angles that you can see in this sixth diagram where the colours are the same, they obviously all represent corresponding angles, so therefore will be the same size. Now our next relationship that we look at is what we call alternate angles. Now alternate angles were more formally known as a Z angle. Now again, with Z angles, they are exactly the same. So as you can see in our main diagram here, that I've got a Z angle. So here I've got a Z, and so these angles here are going to be the same. So they are the same size. So if one angle, and they're both acute in this particular example, however, they could also be obtuse as well. So again, obviously we no longer call them Z angles, we call them alternate angles, and again, reason why is because you may not necessarily see the Z as explicitly as in the diagram. So here we can see that in this, now if I just mark these lines here, so although this doesn't look like a Z, because it looks like this, it's actually like a backwards Z, a Z that's been stretched. So basically, however, under this notion, those two angles that I've drawn here would be the same. If I look on the next question, I can draw a Z. So again, more formally there. So these two angles would be the same. In the third diagram, I can draw a Z like so. So again, this angle will be the same as this angle. On the fourth diagram, I can draw a Z that looks like this. So this angle here is going to be the same as that angle there. I can draw another Z like so. So this angle here is going to be the same as that angle there. And I can also draw a Z on this diagram here like so. So this angle will be the same as that angle there. So try not to, although Zs will help you, it may not look like a more orthodox Z, so just be wary of that. It could also be, don't always look for Zs that look like that. It could also look like an N, or it could be a reflection of that, so it could look like this. So it's different variations, different rotation reflections that you need to be able to spot, and it's really difficult to kind of teach this particular topic, but it's all about whether you see it or not. So all I can do is kind of give you instructions of what to look out for. So try and look out for a Z, and those two angles would be alternate and also therefore be the same size. Now moving on to our third relationship, which is what we call a co-interior or supplementary angles, or sometimes known as a C angle, formerly known as a C angle. Now with supplementary angles, or co-interior angles is more commonly known as now, they are basically, those two angles add up to 180. So if you can see as some form of a C, then this angle here, which is an obtuse angle, and this angle here, which is an acute, will add up to 180. So again, it's really important that you're able to spot these two. So basically, it's angles created by the two parallel lines themselves. So if I just quickly mark what lines are parallel, again, when you're marking parallel lines, it doesn't really matter what direction the arrows are going. So looking at this angle here is going to be, what should I say, this angle and this angle are not the same, because again, one's obtuse, one's acute, but those two angles there will add up to 180 degrees. And likewise, this angle here and this angle here will add up to 180. And like so, if I go for this angle and this angle, those two will both add up to 180, and these two angles here will add up to 180, these two angles here would add up to 180, those two there would add up to 180, these two green angles would add up to 180, and so forth. So it's just something to look out for. Now, co-interior or supplementary angles is probably the odd one out, because they're the ones that will add up to 180. All the other previous two relationships are basically the same. And it's kind of like, with these types of questions in an exam, just use your common sense. If a question, look, although the diagrams will never be drawn accurately or to scale, obtuse angles will be obtuse, they will look obtuse. Acute angles will look acute. So if they're both the same type of angle, then that should give you an indication of whether they're going to be the same or not. If one's acute and one's obtuse, then you probably need to take away from 180 to work out what the other angle is going to be. But it's just something that you do need to look out for. Now, not connected to parallel lines is another relationship that we notice, which is horizontal or vertically opposite angles are going to be the same. So for example, on this diagram, that here when we've got X, that this angle here and this angle, which is vertically horizontally opposite, I should say, are going to be the same. And likewise, if I use a different color, that this angle here is going to be the same as this angle here. And again, so those two green angles are both going to add up to, are going to be the same, sorry. So in terms of this, if I had to mark what angles are opposite, so these two angles here are opposite, those two angles there are opposite, this angle here is opposite to this one here is equal to this one here, this angle here is equal to that angle there, and this angle here is equal to that angle there. That one is equal to this one. That one is equal to that one. And this angle is equal to this angle. This angle here is equal to that one. And again, just marking what the other ones are. Now you just need to be careful because obviously I'm using the same color on the diagram, so don't think that all the green ones are going to be the same. And likewise, this angle here is going to be the same as that one. That one's going to be the same as that one. This one, same as that. That's the same as that one. This one, and that one are going to be the same. Let's just finally mark the last one. So this one's the same as that one, and this one's the same as that one. So as you can see, the templates for each of these sort of mini diagrams and drawing can be replicated for all the other angles as well. So there are basically 4 types of relationships you need to look out for when you're given this question. You need to look out for corresponding angles, which are more commonly known as F angles, alternate angles, which are formerly known as Z angles. You've got co-interior or supplementary angles, which are like your C angles, and now you've got horizontally vertical or vertical opposite angles. And again, they're either going to be the same or they're going to add up to 180, but it's just important that you know the names of the labels and obviously refer it to the correct explanation of these angles. Now, as well as these 4 types of relationships, it's really important that you don't forget the basics. Now, the basics in terms of angles and lines is that angles on a straight line add up to 180. So this angle here, now this angle is obtuse, so I could say it's going to be 120. So if I then want to work out what this angle here is, all I need to do is do 180 minus 120, and that'll give me an answer of 60, which looks about correct because this is an obtuse angle, this is an acute angle. Now also the next one that we need to be aware of is angles around a point add up to 360. So angles around this point here will all add up to 360. Now if I just get rid of that marking, so let's say I know that this angle here is, let's say, 30 degrees. Now I know that this angle here is also going to be 30 degrees because they are opposite. Now I also know that this angle, so let's say if I knew what this angle here was, let's say that there is, let's say, 70 degrees, then this angle here is also going to be 70 degrees. And I also then know that because that green angle and the pink angle lie on a straight line, that this angle here is, if I just emphasize that straight line, to work out this red angle, all I need to do is do 180 minus 30 minus 70, which gives me an answer of 80 degrees. So this angle here is going to be 80, and therefore this angle here is also going to be 80. Why? Because they are opposite. Now from this, what I can then do is also work out what some of the other angles are. Now again, the key thing you can also see, hopefully in this, is that I can also see a triangle. Now if I just emphasize that triangle with the purple line, and I've got a triangle here. So let's say I was given that this angle here was 60 degrees, and I want to work out what angle this is. Let's just call that angle X. Well, to work out what that angle is, I need to first of all work out what this angle here is. And how do I work out what this angle? Because I know it's inside a triangle, I'm going to do 180 minus 70 minus 60, which gives me an answer of 50 degrees. So this angle here is 50. And then remembering that angles on a straight line add up to 180, so to work out what X is, all I need to do is 180 minus 50, which gives me 130 degrees. Now, in terms of this particular question, it's just something, obviously you need something that you do need to work out with. Now, obviously this diagram is not going to be drawn accurately, and the reason for this is because that these two angles here should add up to 180, but because they're not parallel, there's no markings that they're parallel, therefore I can't use that these two angles here are supplementary, because there is no markings to give me an idea that those two angles there are parallel. However, if they were parallel, then the angle X, all I'd have to do is it would actually add up to 150, but it doesn't, unfortunately. Now, in terms of some top tips that I recommend that you abide by, so a good tip is with angle questions is always use your common sense. So just ask yourself, are angles both acute? If they're both acute, then there's a good chance they'll both be the same. If the angles are obtuse, are they both obtuse or are they both different? So again, that's how you kind of decide what it is going to be if you were guessing. But like I said, it's important that you try not to guess to learn the actual correct method. The second one is it's really important you learn the names of the angles, and obviously writing these will explain your answer, because a lot of these questions will ask you how do you know that this is it, because obviously it's not drawn to scale, and which what we would have to do is recall the actual name of the relationship. So either writing that the angles are both corresponding, that they're both alternate, or they're both co-interior, or that they are opposite each other. Now you may need to find an unmarked angle before finding the angle that you want. If stuck, try and write down the angles of all the angles that you can see, and this sometimes will help you. So more complicated questions will get you to find out other angles before you actually find the angle that they do want. So just be careful and mindful of those. Now another thing is that you can always mark angles on a diagram. Now before a couple of years ago, that any markings on diagrams would not be marked in exams. However, now that is now allowed. So if you write any markings or marking like the numbers of angles on your diagram, then that will get marked. So use your diagram. You don't have to write everything down in nice polite sentences. But the key thing is always make sure that you write your final answer in the allocated space. Now again, we don't want your answer to look like a treasure map where whoever's marking has to look for your answer. It should be basically clear and highlighted in the allocated space. Now this next one sounds very simple, but again, there's a lot of students I know have done this, is never use a protractor for these types of questions. Although the question asks you to find an angle, and an angle measure or protractor allows you to do that, the diagrams will often never be drawn accurately, or it will say this in the question. So it will say that it's not to scale or it's not drawn accurately. So therefore, it's implying that you need to use the rules that we've gone through. Now again, if stuck, look for F angles, look for corresponding angles, look for alternate angles, look for co-interior angles, and look for opposite angles. Now remember that these letters, so to say, can be reflected, rotated, and stretched. So sometimes it may not look like an F or a Z or a C or even an X, but again, hopefully that should help you discover what the angles need to be. And also the last one, if a question has multiple angles to find, it's often easier to work them out in alphabetical order. So if you've got a question where it's asking you to find angles A, B and C, or X, Y and Z, then have a go at working out what X is first, then Y, then Z, or A, and then B, and then C. Usually it's not essential that you do this, but generally the angles will be connected. So it's a lot easier if you do it in the alphabetical order that you can see if a question has got multiple angles for you to find. So let's have a look at some example questions. So in this first question it says that angle EFB is 108. So let's mark what angle EFB actually is. So it's starting at point E, then going to F, and then going to B. And it's this angle here which has been marked as 108. And the question is asking us to mark what angle X is. So angle X is this angle here. So using the properties that we've gone through, we can see that both these two angles that have been given is obtuse, and this one, angle X, is also going to be obtuse, and obviously they are opposite each other, so it's fair to say that angle X is going to be 108 degrees. And the question is asking us which one of these justifies your answer. Well, they are opposite each other, so it's going to be C. Now another way of working out this particular angle is knowing that this angle here is on a straight line. So if I worked out what this pink angle is, and I can work that out by doing 180 minus 108, which gives me 72 degrees, then this angle X also is on a straight line. So if I use a different color, let's go for dark green. That's actually let's go for red. So if I look at this red line, I can see that these two angles are on a straight line. So to work out what angle X is, if this is 72, I've got to do 180 minus 72, which gives me 108. So just another way of working out the angle, but ideally the easiest way of looking at it is knowing that it's opposite, so therefore going to be the same. Now one thing I would suggest that you do when working with these questions is, if you ever do get stuck with these types of questions, is to try and remember the sketch of what the angles are. So opposite angles are the same. So can I see this in this diagram? Well, hopefully by making a few markings or colouring in the angles, hopefully you will spot that they are the same. You can also say, well, can I see an F anywhere? Can I see a Z anywhere? Or can I see a co-interior or supplementary angle anywhere? And again, it's just important that you're able to do this. Now, I personally can see every single one of these 4 types of relationships in this particular question, but what you want to do is refer it to the information that's given to find the angle that you want. So let's move on to another example, again very similar. So angle ABF is 77 degrees and find the angle X. So looking at this, I can see that, well, I can see a Z, I can see an F, I can see a C, I can see opposite angles. But ideally, what you want to look for is this. So I can see that they are a alternate angle. So because they are alternate angles, which kind of answers angle B, the angle X is also going to be 77 degrees. Now again, another way of looking at it is thinking, well, okay, let me just get rid of some of these colours. That's similar, so let's go for purple actually. So here we can see that if I highlight this, I can also see an opposite F, and an F that's the wrong way around. So this angle here is going to be the same as this angle here. So that therefore is going to be 77 degrees. And this angle here that I've highlighted in purple is opposite angle X. So that's also going to be 77. So there are multiple ways in which you could answer the question. It's all about what you find easy, but the most efficient way and easiest way of explaining why angle X is 77 is because it's alternate to the angle ABF. So looking at the next one, which again is very, very similar to what we've done. So looking at this question, I can see angle X, and it says is what I've got to find, and it says EFG is 80 degrees. So this angle here is 80 degrees. Now this is the angle that I'm trying to find, and hopefully you can spot that I've got an F. I just highlight that in pink, and so these 2 angles are going to be the same. So X equals 80 degrees. And then just got to think back to what is the official name of an F angle? Well, that's going to be corresponding. Then moving on to the next question. Now again, here are a lot of letters, and this will be classed as a high level question, but it's important that you establish what the actual questions mean. So here it says that angle X, the lines X, Y and BD are parallel lines, and you can see that with the little arrows that you can see that are drawn on the diagram. It also says that X is a point on the line AB and C is a point on the line BD. So it's just random points that are fixated on those 2 respective lines. And it says that the lines X to B, or the distance between X to B and X to C, are both the same. So here, these lines will obviously not mean that they're parallel, because they definitely don't look like parallel lines, but it means that they are equal length. Now that information therefore implies that the triangle I can see between B, C and X is an isosceles triangle. And what's special about an isosceles triangle is not only 2 sides are the same, but these 2 angles at the bottom will also be the same as well. So the question saying is complete the sentence, angle XBC is equal to 55 degrees. So let's first of all, now let's first of all mark what angle XBC actually is. Well, that's the angle X to B to C. So what they're saying is explain why this angle is 55 degrees. Well, the reason why I know that's going to be 55 degrees is because I can see an F. It's an upside down F that's been rotated and reflected. And what do we call F angles? Well, we call them because it is corresponding we don't have to write the inverted commas, but it's corresponding to angle A, spell angle correctly, AXY, which is 55 degrees. And there will be our perfect answer. Now the question then says work out the angle BXC. Now BXC is, and again I might have to get rid of some of these markings because I've lost where B is. There it is. So angle BXC is B to X to C. So it's this angle here that I'm trying to find. Well, if I take that triangle out, as I've already mentioned that the triangle is isosceles, so this angle here is 55, which means that this angle here is going to be 55, and this is the angle here of what I'm trying to find. Well, I know that angles on a triangle add up to 180, so here I've got to do 180 minus 55 minus 55, which gives me an answer of 70 degrees. So the answer for the angle BXC, so BXC with a little hat, or I could write it as angle BXC is going to be equal to 70 degrees. Let's move on to our next question. So the next question then says work out the angle X. Now this one is a little bit more tricky because obviously X is not really connected to the angle that I've been given. So let's have a look at what angles I do know. Well, I know that this angle here is going to be 80 degrees. And why is that? Because it's on a straight line. I also know that this angle here is going to be the same as that green angle because it's, again, I can see an F, so it's corresponding. It's corresponding to angle CBA. So here, in terms of explaining your answer, well, we can say here the angle CBA is equal to 80 degrees because it's on a straight line. And CBA is equal to BFE because they are corresponding. And writing your explanation just like that would be absolutely fine. And so therefore BFE is equal to 80 degrees. And there is my final answer. And so writing your explanation with those titles of what type of relationship you're looking at is going to make your life just that so much easier. Now, in terms of exam questions, if I was to write 18 and write your explanation just like I've done here, then that would be absolutely fine. But obviously, you want to try and make sure you're writing it in the space that's provided for you to write it accordingly. Let's move on to our next question. So here it's again very, very similar. So it's work out angle X. Well, let's have a look. So I know that this angle here, so I can only work with the numbers. So let's see if we can try and work up to X. So I know that this angle here is on a straight line. So therefore, that's going to be 75 degrees because it's on a straight line, and that this angle here is corresponding because you can see an F in there, and let me just emphasize what that F actually is there, so we know it's corresponding, so that would be there. So X equals 75 degrees. And explaining your answer, well, because again angle EFB is equal to 75 because it's on a straight line, and angle EFB is equal to ABC because they are corresponding. Now obviously there's different ways in which you could answer this question. As long as you're using the correct answers and you get an answer of X equals 75, then that would be absolutely fine. So for example, you could have gone for, let's say, let's use different colors, go for purple. So I could have gone from 105, that this angle here is going to be 105, that this angle here is supplementary, so that's going to be these two purple angles are going to add up to 180, and then angle X is opposite this angle 75, so therefore it's going to give you the same answer. So there are different ways in which you could explain your answer, and as long as you're doing it correctly, that will be justified in the marks that you get. So let's look at this next complex question. So here it says that AB is parallel to CD, and again that's highlighted with these two arrows that you can see. Now the question is asking us to find the value of angle X. Now angle X is here, so using the angle 69, we can see that X is going to equal 69. Now it's not asked me for any explanation of this, but again I could easily have worked out what angle X is by looking at these two angles being supplementary. So this angle here is going to be 111, and then do for X it's going to be 180 minus 111, which gives me the same answer. So there are loads of different ways in which you could answer the question. Now the next question then says to work out angle Y. Now this is the problem now, because obviously these two lines here are not parallel, that the angle X and Y are not supplementary. So let's just get rid of those two arrows because it's not the case. So for this, what I need to do is recognize that I've got a four-sided shape. I've got a quadrilateral. Now angles inside a quadrilateral all add up to 180. So it's 360 rather. So this angle here is 69. Now I know that this angle here is also going to be, well, to work out this red angle, it's on a straight line. So to work out this angle, I need to do 180 minus 69, which gives me 111. Now from this, I can then work out what angle Y is, because these four angles added together must equal 360. So if I do 360 minus 111 minus another 111 minus 69, then that will give me what the angle is going to be. And so working that out, I've got 360 minus 111 minus another 111 minus 69 gives me the answer of 69 degrees. Now another alternate way of doing this, so let me just get rid of all these markings, is I could have also noticed that because my two parallel lines are AB and CD, that this angle here and this angle here are co-interior. And what do we know about co-interior angles? Well, they all add up to 180 degrees. So let me just get rid of all of this. So recognizing that those two angles are co-interior, then all I need to do is do 180 minus 111, which gives me the answer of 69 degrees. So again, y equals 69 degrees. And again, it's all about your interpretation, how you see things. Not one way is the right way, as long as you're explaining yourself correctly mathematically. So it's just important to look out for those types of things. So looking at this next example, so here you can see we've got multiple letters. So I've got A, B, C, D are angles that I need to find. Now in terms of finding out those angles, yes, I could work them out just by knowing which one's which, but I would say trying to work out alphabetical order is one way to look at it. Now a key thing to note on this, that is not drawn to scale, so my protractor should stay in my pencil case and stay nowhere near working through this question. So in terms of working out angle A, which is here, I notice that angle A and 79 degrees are on a straight line. So to work out angle A, all I need to do is, well, let's get rid of this E with a bracket. So angle A is going to be 180 minus 79 degrees, which equals 101 degrees. And again, how do I know that? It's because it's on a straight line. Now this question is not asking for any evidence or any reasons as to why these angles are, but again, I would say it's good practice just in case in an exam it was to ask you why. Now angle B, now what I can see is I've got two sets of parallel lines, and those two parallel lines make the base of that C. So it's both the top and the bottom of that C. So therefore B is going to be equal to 79 degrees. Why? Because it is co-interior or supplementary, whichever you prefer in terms of what you've revised the name of that entry. Now in terms of angle C, now angle C is not supplementary or co-interior with B because the two parallel lines are not the base and the top of that C. So to work out angle C, now one thing I notice about angle C is that it's opposite to this 83 degrees. So angle C is going to be 83 degrees. Why? Because it is opposite. Now you don't need to go for a horizontal or vertical opposite. Opposite would be absolutely fine. Then angle D, well, I know that all of this, now unfortunately I don't know what all the angles are, and again in terms of the parallel lines I can't say that this angle is going to be 79 because this line and this line are not parallel. So what I've then got to do is notice that these four angles make a quadrilateral. So let me just highlight that different colour. Let's go for purple. So these angles here form a quadrilateral. So this angle here is A, which is 101 degrees. I know that this angle here, which is B, which is 79 degrees. I know that this angle here is 83 degrees. So it's this angle I've got to find. Now angles inside a quadrilateral add up to 360. So if I add up all of those angles, so 101 plus 79 plus 83, and quickly do that on my calculator. So 101 plus 79 plus 83 adds up to 263. So therefore 360 minus 263 is going to give me an answer of 97 degrees. So angle D is 97 degrees. And there is my final answer. Now again, when you're doing these questions, always make sure that you're highlighting what your answers are, because you've got numbers floating all over your page. So it's always worth highlighting either by underlining or with a highlighter or a bubble around them. So let's move on to our next question. So the next question here says find the angle of X. Now again, there's no explanation that we needed for this, but one thing I do notice is that it forms a Z. So angle X therefore is going to be 60 degrees. And why is it 60 degrees? Because it is alternate. Now again, you don't have to write down the reason, but it's very good practice if you can try and specify what it's in. It's also a good way of remembering what the names of the angles actually are as well. So here again, so using my highlighter, I can see that I've got F, And so this angle here is going to be the same as this angle here, so that's also going to be 105 degrees. And again, why is because it's corresponding. Now you only need to write down the names if a question asks you to explain your answer or give a reason why you've given your answer as it is, but if it doesn't, just 105 would be absolutely fine. Moving on to the next one. So this angle here, which is x, is opposite angle 65, so therefore x is going to equal 65 degrees. Moving on to our next question. So here we've got angle x. Now, angle x and 51 aren't connected by either an F, a Z, or a C, or even directly opposite. So what I'm going to have to do is find out what some of these missing angles are by using the facts that I know. Well, I know that if I sort of colour this angle here in pink, that is going to be the same angle as angle x. Also, what also is going to be the same angle as angle x is this angle here because it's opposite. So this angle here is going to be equal to x because it is corresponding. This angle here is going to be equal because it is opposite. And those two pink angles also form a Z because they are therefore alternate. Now, if this angle here is going to be the same as x, and therefore this angle here is also going to be the same. So to work out what this angle here is, well, I know it's on a straight line, so I do 180 minus 51 equals 129 degrees. So therefore, that this angle here is going to be 129. So if that's 129, this is 129, so x is going to also add up to 129 degrees. Now, if you've got the answer 129, but you did it in a different way, then that's absolutely no problem at all. As long as you've got the answer 129, it's going to be marked correctly. So looking at our next question here. So angle x, well, I know that this angle here is going to be the same as angle x because it is corresponding, because you can see I've got F there. So working out what this angle is, well, I know that that's on a straight line to 47. So if I do 180 minus 47 gives me 133. So this angle here would also be 133. So x equals 133 degrees. Now moving on to our next question, it says that ABCD is a parallelogram. And the question is asking me to work out the angle of x. Now in terms of a parallelogram, let's have a look at what lines are going to be parallel. Well, these two here are going to be parallel, and also this line here is also going to be parallel to each other. I'll mark that with two little arrows. Now from this, now it's going to be quite difficult for you to spot, but what I can spot straight away is I've got a Z or an N, as you may see it as. Now with that, I notice that if I just tilt my head and I've got my C, my Z, that this angle here is going to be the same as this angle here. So therefore x is going to equal 47 degrees, and as an explanation why is because it's alternate to the angle D. Well, unfortunately it hasn't got a marking there, so let's just call that E. E, and that hasn't got a marking, so let's just call that F, like so. And that will be the reason why. So moving on to our next example with the value of x. Now this one thing I noticed, unfortunately, because we don't have numbers doesn't mean we can't actually work it out. So here are my parallel lines, and I can see that it forms a C. Those two angles that I've marked form a C. Now what do I know about C angles? Well, they're more properly known as co-interior angles, and that those two angles added together must add up to 180 degrees. So if I add 4x plus 5x, that should give me 180 degrees. Now 4x plus 5x is 9x. So something times 9 equals 180. Well, if I divide that by 9, then I'm left with x equals 20. So x equals 20 degrees. Now a question might ask you then to find out what these two angles are. So 4 times 20 would be 80. And 5 times 20 would be 100. So if a question did ask you work out the size of those two angles, then you would use your x value, substitute it in, and you would get the actual answer of those two angles. So moving on to our next question. So from this, you just want to highlight what you can see. Now in this particular question, I can't see any parallel lines because there's no marking of the lines. But what I can see is I can see a lot of opposite angles, and I can see a triangle, and I can see lots of straight lines. So what I'm going to do here is I'm going to work these questions, the missing angles out in alphabetical order. So let's work out what A is first. Now I know that A and this angle of 21 is opposite, so A equals 21 degrees. Now to help me, I'm just going to label that as 21 degrees and just colour that in, so I know what that is. Now I need to work out what B is. Now B is on a straight line, so if this angle here is 110, then this angle here must be 180 minus 110, which is 70 degrees. So this angle here is 70, so if I write B equals 70, and then what I can then do is colour this angle in so that I can kind of ignore it. Now the next thing I then need to do is find out what angle C is. Now angle C, well, is part of a triangle. So if I take that triangle out of the diagram, like so, and I got this angle here is 70, this is 21, and this is the missing angle that I need to find, well, all those three angles need to add up to give you 180. So if I do, so 70 plus 21 plus x adds up to 180. So if I add these together, get 91 plus x equals 180. Take that 91 over to the other side by subtracting it. So x equals 89 degrees, and there is my final answer. Or should I say C equals 180, 89 degrees rather. And so there are my final answers. And let me just quickly get rid of those x. Change that for a C. Not there, but I'll see there. So let's have a look at our next question. So again, next question, I can see two parallel lines, so that's this line here, and its question's asking me to work out what angle X is. Well, looking at this, I can see that it's opposite the 49, so X is going to equal 49 degrees. Why? Because it's opposite. And working out Y, well, working out angle Y, well, I can see I could probably work out what this angle here is, because its angle's in a triangle. However, it's not going to help me work out what angle Y is, apart from the fact that this line here is like a C angle. The most easiest way of spotting what C is, what Y is spotting I can see a Z. Now because I can see a Z, it means that this angle here is going to be the same as this angle here. So therefore, Y is going to equal 63 degrees. And why? Because it is alternate. Now again, there might be different ways. You may have gone a longer route, you might have gone a shorter route, but as long as you get an answer of 63 degrees, that's going to be absolutely fine, because in this question it's not asking for an explanation, but if it did, you could easily write down what the steps were for you to find out what the angle Y and X were respectively. Now these questions are really a bit of a challenge, and it's one of these types of questions that as a teacher it's really difficult to teach. And the reason for that is because there are so many different ways of getting the same answer, and it all depends on what you can actually spot in a diagram. So for example, if I look at a diagram, it might take you about, for some people it might take a minute to work out what the answer is, for some it might take 10, and it all depends on how you interpret it. And one of the tips I would suggest that you do is look out for the key things. Look out for parallel lines, look out for triangles, look out for opposite angles, look out for Z angles, also known as alternate angles, look out for F angles, properly known as corresponding angles, and look out for co-interior angles, also known as C angles or supplementary. So they're just key things you need to look out for. So I would have a marker with you, have a practice, work. Another good tip is to find out what other missing angles are. Just because a angle hasn't been marked either with a number or a letter doesn't mean that it's going to be impossible for you to work out what it is. And you will find that a lot of high level questions will involve you finding other angles that aren't connected to the answer in order for you to find the answer of the size of the angle that they're looking for. Now we'll put some practice questions in the description below for you to practice everything that's been covered in this video.